Okay, let's do 3.2, number 7. So number 7, it gives us g of x is equal to x squared plus 2x minus 3. It says to rewrite that thing. Hey, what's up?
Hi. I was here earlier.
Oh, cool. I'm just making a homework video.
Okay.
So number 7 is this, and it says that we need to rewrite this in standard form and give the vertex. We know it means vertex form. So a is 1, b is 2, c is negative 3. So I write down a x minus h squared plus k. I already know that a is equal to 1, so I'm done with that part. Because I need to find 3 parameters, a, h, and k. If I can find those 3 parameters, I will be done. So I let the reader know I'm going to find h. So that's negative b over 2a. So it's negative 2 over 2, 1. So it should be negative 1. And then I find k, but k is just f of h. So it's f of negative 1. So that means we put negative 1 and square it, which is positive 1. Plus 2 negative 1 is negative 2. Minus 3, so it's minus 5, and 1 is minus 4. So I have my k and my h, my a. Thus, I know y is equal to, 1, and then x minus h plus k, so it's this. Right. So it's 7, 8 is f of x is equal to x squared minus x. So as I also cleared that the vertex is negative 1, negative 4, in case that wasn't clear. For here, if this is my function, I think that we're saying that a is 1, b is negative 1. And since it wasn't there, c is 0. So I'm going to say that I already know a, and I'm going to say find h. That's, again, negative b over 2a. So it's negative 1 over 2 times 1. So it's a half. And then to find k, k is f of h. So it's f of a half. So it's going to be a half squared minus a half. So it's going to be a quarter minus a half, which is negative a quarter. Thus, y is equal to a is 1, x minus h squared, minus h squared plus k. So it's going to be that. All right. Notice another way that we could have seen that is this thing, x squared minus x. It's going to have zeros since it's x squared minus x. This is a note. This is not part of the problem, but do you see that it's x minus 1? That means it has zeros at 0 and 1. And so we would think that that axis of symmetry is going to be in between 0 and 1, and that's why it is at a half where it is. Again, this is just a note to make sure you saw what was going on. We'll talk more about finding zeros in an upcoming lesson. So then we talk about 11. 11 is k of x, 3x squared minus 6x minus 9. Again, I'll let the reader know what a, b, and c are. So if it wants me to find a, x minus h squared plus k, I know I need to find h, which is negative b over 2a. So it's negative 6 over 2 times 3. So it's 6 over 6, which is 1. Then I find k, which is just f of h. So it's f of 1, which means it's 3, 1 squared minus 6, 1 minus 9. It's 3 minus 6 minus 9. Which should be negative 12. Okay. On that last one, did I say very clearly? I didn't. The vertex is a half, negative a quarter. For this one, I'm going to say, look, the vertex is 1, negative 12. So y is equal to a x minus h squared plus k. All right, that's 11. 17. 17 is what? Determine if it has a min or a max and find the value and the axis of symmetry. Oh, here when it says find the value, it means find the value of the max and the axis of symmetry. So if I'm looking at 17, its f of x is equal to 4x squared plus x minus 1. Well, since a is positive, that means it opens up, which means it has a minimum, because it's going to look something like this. So when it says find the value, it wants to know what is that minimum value. So find minimum is the same as find the vertex. So I'm going to find h, which is negative b over 2a. I know that a is 4, b is 1, c is negative 1. So this is negative 1 over 2 times 4, so it's negative an eighth. So then to find k, that's f of 8 poop. K is equal to f of h, so it's equal to f of negative 1/8. So it's going to be 4 times negative 1/8 gets squared minus an eighth minus 1. So it's going to be 4 over 64, but it's negative, right? Negative 1/8, but I know that 1/8 is the same as 8 64ths, because I multiply it by 8 over 8. And minus 1, which is negative 64 64ths. So those are, first off, this first one should be positive because it's squared. So that's actually positive, my bad. So these two together give me negative 4 64ths, and this is negative 68 64ths. Turns out to be my k. That's going to be 34 over 32. And then you take out another 2, and it's 17 over 16. So my vertex is negative 1/8, negative 17 16ths. Thus, min is y is equal to negative 17 16ths occurs at x is equal to negative 1/8. And so axis of symmetry is x is equal to negative 1/8. And that's all that. So that's 17. Then 19. 19 is going to be the same sort of deal. 19. And I think I'll stop after 19 and then do the other part in a minute. So f of x, or maybe not. F of x equal to 1/2 x squared plus 3x plus 1. Okay, so a is equal to 1/2, b is equal to 3, and c is equal to 1. Again, does it have a min or a max? A positive implies that this thing has a minimum. And so to find that minimum, I'm going to find h, and I'm going to find k. So h is negative b over 2a. So it's negative 3 over 2 times 1/2. So it's negative 3. But k is f of h. So it's f of negative 3. So it's 1/2 negative 3 squared plus 3. Negative 3 plus 1 is positive 9/2 minus 9 plus 1. But negative 9 is just negative 18 over 2. And 1 is just positive 2 over 2. So I have 11 minus 18 is negative 7/2. So, let's see. Again, a is positive opens up. So min is y is equal to negative 7/2, comma, and it occurs at x is equal to negative 3. Also, axis of symmetry is x is equal to negative 3, because they're the same thing. So it's 1923. This is determine the domain and range. So for 23, f of x is equal to x squared plus 6x plus 4. Domain and range. Well, again, a is positive, so it opens up. So you're going to have some minimum value, and then your range is just going to be that y value on up. And the easy thing is, we know that the domain is negative infinity to infinity. It's all reals. And now we get to find the range. So the range, we're going to have to find that vertex and have it open up. So I'm going to find h. I'm going to find k. So h is negative b over 2a. A is 1, b is 6, c is 4. It's negative 6 over 2 times 1 is negative 3. So k is f of h. It's f of negative 3. It's going to be negative 3 squared plus 6, negative 3 plus 4. So it's a positive 9 minus 18 plus 4 is negative 9 plus 4, which is negative 5. So my function actually is down here. So I can grab this and make it go up this way. My function actually does something like this, where the bottom of it is down here at y is equal to negative 5, and it opens up. So that means my range is negative 5 and then everything above it. So it includes, but we never include infinity because it's not a number. It's 23, 25 is the same sort of dealio. 25 is the same sort of thing. K is equal to 3x squared minus 6x minus 9. A is 3, B is negative 6, C is negative 9. I know opens up, got a vertex, and so the range is everything above it. The great thing is that the domain, because it's a polynomial, is all real numbers. I have to go find the range. To do that, I'm going to find h, and I'm going to find k. So h, negative b over 2a, is negative 6 over 2 times 3. 6 over 6, which is 1. K is f of h, so it's f of 1, which is 3, 1 squared minus 6 minus 9. So it's negative 15. And 3 is negative 12. So really this thing is all the way down here somewhere. Actually, let me delete it. So it's somewhere way down here. So grab this, pull it down here. And I know when it opens up, it's going to look something like this. Where this point right here, when you plug in 0, is negative 9. And this one down here is y is equal to negative 12. Just wants to know we're in here. And so if you open up, it's going to be from negative 12 up as far as you want to go. All right, that's 25. 29, it says solve. Yay. X squared plus 27 equals 0. Yes, you could use the quadratic formula with a equal to 1, b 0, and c 27. Or if you just subtract, you get this. You take the square root, you get plus or minus negative 27. Don't forget your plus or minus. But you know that that is square root of negative 1 square root of 27. So that's I squared to 27. But then you know 27 is just square root of 9 times 3. So square root of 9 is 3. So it's 3 square roots of 3. So this is plus or minus 3i square roots of 3. Those two answers. That's 29. Then 37 is x minus 4 equals 20. Again, a lot of math and science is about form. So I could use the quadratic formula. I could solve. In this case, I like equal to 0 because I can factor it. I wish I could have factored it. It's not going to factor out nicely, is it? Because to get to 20, you either have 1 and 20, you have 2 and 10, you have 5 and 4, and none of those will give us a difference of 4, so I'm going to have to use my old buddy, the quadratic formula. Negative b plus minus root b squared minus 4ac all over 2a. In this case, a's 1, b's negative 4, and c's negative 20. So it's going to be a negative 4 plus minus root negative 4 squared minus 4 times 1 times negative 20 all over 2 times 1. So it's 4 plus minus root 16. This is always going to be positive because it's squared. So this is negative 4 got squared. Oops. Negative 4 got squared. Minus is a plus. So that's plus 80 over 2. So it's 4 plus or minus square root of 96 divided by 2. Notice when you add those digits, you get 15 for 9 and 6. And because the sum of the digits is divisible by 3, I know the whole thing is going to be divisible by 3. So 3 times 3 is 9. I'm going to get 0, 6. It's going to be 32, right? Because we're awake. So that's 3 times 2 times 16. 16 is 4 times 4, yes? So there's our perfect square. So 3 times 2 times 16 is what 96 is equal to. Over here on my scratch work. And so any perfect square you can pull out, the square root of 16 is 4, and then that 3 times 2 is left over, so it's just 4 root 6. So this is equal to, let me move all of this. First, let me resize it. Let me put it right here. So this is 4 plus minus 4 root 6 over 2. But that's 4 over 2 plus minus 4 root 6 over 2. So that gives us a half plus, I'm sorry, not a half. That gives us 2. 2 plus 2 square roots of 6. And don't forget it's plus or minus because we expect 2 answers. Okay, so that's 37. So almost done. I just have one left, 43. And it's x squared plus x plus 2. A is 1, B is 1, and C is 1. Thank goodness it's set equal to 0. I think you'll agree if you think about it long enough that it cannot factor, and you must use the quadratic formula. So you're going to get negative 1 plus minus square root of 1 minus 4 times 1 all over 2 times 1. So you get negative 1 plus or minus square root of negative 3 over 2. So it's negative 1 plus minus I square root of 3 over 2. So it's negative 1/2 plus minus I square root of 3 over 2. So those are two complex numbers. That is it. Have a great day and bye.